Hi there. Thanks everyone. Thanks for joining the session here today on the Azure Community Conference. My name is Erwin Staal. I'm an Azure architect and a DevOps consultant, and I live in the Netherlands. I work for a company called 4.net, and we do consultancy and training, etc., all on the Microsoft stack. So today we're going to talk about KEDA, and KEDA stands for Kubernetes-based event-driven autoscaling. So that means that KEDA enables you to do proper autoscaling based on events, and that is, as we will see in a bit, something that Kubernetes cannot do out of the box. But KEDA actually makes it very, very simple to do autoscaling based on events. So before we dive into KEDA, let's quickly discuss containers and Kubernetes for a bit, so that everyone who's watching and who might not be too familiar with containers or Kubernetes can still follow along in this session and is still able to understand where KEDA fits in the picture and why it's here to help. So first off, containers. You should probably see containers as a package that contain whatever your application needs to run. So that means that a container will contain your code, but also all the dependencies, SDK, system tools, settings, whatever that your application needs to run. You could simply drop that container onto any machine that's capable of running a container and it will run. You don't have to install any other dependencies or whatever on the VM, for example. That's all in your container. So, but running just one container isn't that useful, especially not in production where we want things like high availability, fault tolerance and whatever. So that's where a container orchestrator comes in. And Kubernetes is by far the most popular, most well-known container orchestrator out there. So Kubernetes basically consists of two main components, which are the masters and the workers. So the master is responsible for making sure that whatever you tell it to run in the cluster actually runs in the cluster. And it will continuously monitor if that's the case. And the workers then, on the other hand, are the machines, the VMs for example, that do the actual work. That's where your workload actually runs. So if you then want to run an application on Kubernetes, then you have to write something like this YAML file. And we give that YAML file to the API, which will then make sure that your application runs like you specified in this YAML file. So this is a very simple example. It's far from complete, but it gives you a bit of an idea what kind of things should be in there. So the most important here probably is the image that tells the master what container you actually wanna run on your cluster. So the API will grab the file and will read it and will try to spin up your workload on the cluster. And then it will continuously monitor to see if the workload you specified is still as it's running on the cluster. And if that's no longer the case, because for example we had a power outage or something and one of the workers goes down, then it's the master who will notice that and will move your work into another worker to make sure we still do things like you specified in the YAML file. So let's go back to KEDA again. KEDA is about autoscaling, so let's talk about scaling for a bit. Normally you could say there's two types of scaling, horizontal and vertical. So if you look at horizontal scaling, then we mean that we could add additional machines to increase the amount of compute we have. We could simply add another virtual machine to our Kubernetes cluster. On the other hand, we could also be scaling vertically. And by that we mean that we could add additional compute resources to the machines we already have. So we could increase the number of CPUs, we could increase the number of memory and the gigabytes we have available. So there's horizontal and vertical scaling. If you then look at what options we have in Kubernetes, then this is kind of the table that we get. So again, there's vertical and horizontal ways of scaling a Kubernetes cluster or scaling your workload. So first, horizontal. What we could do in a Kubernetes cluster is scale the number of nodes. So we could simply add additional nodes to get additional resources. But if you would like to scale just one particular workload, so you, for example, run an API in the cluster, you could simply scale the number of instances, the number of pods of your particular API to get more resources. There's also vertical scaling. By that we mean that we could resize the size of the nodes. It depends a bit on where you run the cluster, on what public cloud environment, for example, if this is an option. But sometimes it is the case. So we could resize the node, add CPU, add memory. But what we also could do is resize the pods itself. So we can, at deploy time, limit the resources a specific pod is allowed to use. So, but then we can also increase or decrease that on the fly to resize the amount of resources a pod is allowed to use and do scaling by that. But the problem here is that scaling in Kubernetes is kind of always based on the symptom and never on the actual root cause of why we need to scale. So what that means is that if you want to do scaling in Kubernetes by default, you mostly do that based on your CPU usage or based on your memory consumption. And it's very, very hard by default to do that based on anything else, really. And that is obviously far from ideal, especially in event-driven environments like we have more and more today. So that's where KEDA comes in. KEDA helps you with the event-driven autoscaling on your Kubernetes cluster. And it does that by very strongly integrating with all of the existing components in Kubernetes. KEDA itself is actually pretty straightforward, pretty simple, and that's what actually makes it also powerful. So as you can see in this diagram, KEDA consists basically of 3 parts. First of all, there's the metrics adapter, and that the main job of the metrics adapter is to provide the metrics KEDA consumes. We'll talk about how that works in a bit. But so KEDA consumes the metrics from your event sources, and the metrics adapter is responsible for making the data available to the already existing horizontal pod autoscaler in Kubernetes. And then the horizontal pod autoscaler goes to work and does the actual scaling in your cluster. Then we have the controller, and the controller is basically responsible for scaling your workload to and from 0. So that's an important thing, because by default, Kubernetes can't scale your workload down to 0. You always have at least one instance available of your workload. So that's what the orange line in this diagram means, and scaling down to 1 is done by the horizontal pod autoscaler. But by adding KEDA, we can actually scale down to 0, which has been indicated here by the blue line. So that's the main job of the controller. And then we have the scaler, and it's actually scalars. You probably use more of them. And a scaler is responsible for reading a particular event source and getting a metric from that event source. So in the demo, the first demo I'm going to show you in a bit, we're going to work with the Azure queues, the Azure storage queues. So there is a specific scaler which is capable of reading the number of messages available on an Azure queue, on an Azure storage queue. And it can fetch that number and feed it into KEDA, and then feed that to the horizontal pod autoscaler to drive the actual scaling. So the scaler will go out to the event source and see how many events there are, so you can do scaling based on that. And one last important thing we see here in this diagram is that there is still a line between your pods, your workload, and the actual event source. That is because KEDA does nothing more than the actual scaling. It's still up to your workload to fetch data from your event source and process it. There are alternatives out there to what KEDA does, and some of those alternatives do actually also fetch the data from the event source and push that into your workload. That is something that KEDA doesn't do, and that's a powerful option because that still allows you to work with the event source and use the SDKs of that event source and do the most complex things with that event source that you could possibly do. That is something that the alternatives do not offer, and KEDA does. All right, so here's a list of some of the available scalars in KEDA. There's actually there's actually a few more. They get added almost every week. You can find them on the website in the documentation of KEDA. But what you can see here is that KEDA isn't something that's Microsoft or any cloud vendor for that matter specific. There's various different kinds of scalars for Azure, but there's also some out there for Google Cloud, for AWS, and also some scalars that aren't even cloud specific. So there's a scalar for Prometheus, which we will see later on. But there's also one which allows you to read from a MySQL database and do scaling based on something you get out of it. So there's a wide range of different things you can actually be scaling up on. And that's pretty powerful, pretty cool. So the first demo we're going to see today will actually run on a combination of the Azure Kubernetes service and the Azure container instances. And I think that's a really powerful combination of tools here, especially in an event-driven environment, which we'll talk about today. And that is because if you would normally have a Kubernetes cluster running your APIs, for example, that is a pretty predictable workload. It might scale up and down a bit, but it's pretty predictable. But that's not the case in an event-driven world. So you might have nothing to do on your queue for weeks, and then suddenly you have to process 1 million items because someone is doing an import of data. If you would have to handle that 1 million messages on your existing Kubernetes cluster, that would mean that you have to be able to very, very quickly scale out that cluster. But that's quite hard to do, takes some time. So you will probably be impacting the other services running on that particular cluster. So what we can do is we can leverage the power of the virtual nodes and actually move the work involved with the events onto the Azure container instances and run them there. Just spin up an instance, let it do its work, and then delete it again. And the beauty is that you can still talk to the same endpoint or the same Kubernetes API, but there will be a decision made on where to actually run that particular workload. And that's pretty cool. So then we can do the predictable stuff on a Kubernetes cluster, have dedicated resources available. That's also a bit cheaper compared to running on container instances, but container instances gives us kind of infinite compute power on demand. Right, so let's dive in a demo on that. So the first demo I'm going to show you here today is one in which I'm going to create an Azure function and then put that Azure function into a Docker image and run that on my Kubernetes cluster in Azure on AKS container instances, and then use KEDA to do the scaling of that container. So we're going to start by writing an Azure function, and you can actually do that by running this command. I'm specifying the Docker flag here because, as I mentioned, we're going to do it on a Kubernetes cluster. That also means that we can, by putting it in a container, we can actually run Azure functions wherever we want, not just on Azure, but also on any cloud environment really, because it can run on a Kubernetes cluster. So initialization has been done. Next is that we need to create a new function. So we're going to do that. Azure functions work based on triggers. That's what kind of fires them. So it asks me to select a particular trigger. And as I mentioned, we're going to work with the Azure queue. So I'm going to select the queue trigger. And I'm going to come up with a very original name of Hello KEDA. So it's going to do some scaffolding here. And it shouldn't take too long before my first function is ready to go. There we are. So let's open a code window to see what it actually looks like. All right, so we got ourselves a Docker file from running the first command, and what you can actually see here is that we indeed run in a Docker image, which comes from a Azure function image. So that's in there, and this is actually the Azure function that we're going to run. Here's the Q trigger again. That's what we call in an Azure function a binding. And the beauty of the Azure functions here, and then especially in combination with KEDA, is that I don't have to write any code myself to do an actual connection to the queue I want to read data from. That's all been done by the Azure function runtime by the SDK. So I can just specify that I have a queue trigger. This is the name of the queue I want to read my data from. And all I need to do is specify a connection to that queue. And you guys probably don't want to see me typing. So let's quickly switch over to a working example. This is again the same function we just saw. Here's the queue trigger again, the name of the queue. But here I already specified the name of the variable that holds my connection. And that has been specified in the settings file. So here's the connection string to my storage endpoint. And if I now would want to run this function locally, I could do that by simply hitting func start, and I could debug etc. locally. But that's not really what we're looking for today. We're looking on how to deploy this Azure function on our Kubernetes cluster to actually get it run and scaling using KEDA. So that would require the func Kubernetes deploy command that wants to have a name. So we're gonna specify a name, and I wants to know the registry. Doesn't matter. I'm not gonna run it anyway. It wants to know the registry, because what happens here is the container image will get built. It will get pushed in the Docker registry, and from there it will be downloaded on the AKS Kubernetes cluster and then run. That's basically what happens here. But quite often you want to have a bit more control over how the deployment actually happens. So what we can do here is we can specify that we want to do a dry run, and that we want to have the output of that dry run in a YAML file. So if I would now hit enter, now you do a dry run, and the output is going to be saved to this file. And what we see then is the stuff that would actually be provided to the Kubernetes master with the instructions to start deploying our workload. So what we have here first is a secret that contains the connection string to my storage account. This is Kubernetes default stuff, not KEDA specific. The same goes for the deployment down here. The deployment describes how my workload looks like and how it should be deployed. So for example, here's a reference to my Docker registry and my KEDA demo image that will be downloaded on the Kubernetes cluster. And then down here is actually the first thing that is really KEDA specific, and that is the scaled object. One note here, quite recently version 2 of KEDA has become general available. So you can see I'm still using version 1 here, and I should upgrade. It doesn't really matter for this story. A few things changed, but most of it actually stayed the same, at least from a perspective of the user. So the scaled object specifies how the scaling of my workload should work. So down here, for example, we get a few parameters to control how we want the scaling to happen. So for example, we have the polling interval, which specifies how many seconds we should wait before trying to figure out the number of items on my queue. So every 5 seconds, it will go out to my queue to ask for the number of items. That might be a bit aggressive in production, but it's handy for demos. Another interesting one, for example, is the maximum replica count. So you can actually scale down to 0, but you can also limit the maximum amount of work, maximum amount of pods we want to run. And that comes in handy, of course, if my workload, for example, needs to call an API, and we would just let this scale out to 1 million workers, then we would probably be overloading that API. So this allows us to control it a bit. And down here is then the specification of the trigger, and that will look pretty familiar to you. Again, it's of type QTrigger, and this over here, the connection, is a reference to the secret I showed you a minute ago. That's how it can fetch its connection and go out to that queue and figure out how many items there are on that queue. And then there's the queue name, which it needs to read. So this is actually what it looks like. To get this running, you would just need to do a simple Kubernetes apply with this YAML file. And that is something that I already did, because it takes a while sometimes. So let's have a look at how that scaling actually works. But before we do that, let's have a look at some of the stuff that's been deployed to my cluster. For example, there is an entry in the horizontal port autoscaler, which represents my deployment. And as you can see here, it says that the minimum number of pods is 1. And that is again because Kubernetes itself cannot scale to 0. KEDA does that, so that's why you see the 1 here instead of the 0 you saw me specifying just a minute ago. If you look at what's running currently, then you see that there's nothing currently running. That's because there's nothing on my queue and it's been scaled to 0. But if we do a watch on the deployments, then we see that my deployment is actually there, and that it's been scaled to 0. So if I then run an application here on the background to fill my queue, that's going to load up around 100 items, 100 messages on my queue. That's been done by now, and it shouldn't take too long before we see, and there we go, before we see KEDA kicking in and starting to scale this particular workload. And it's gonna scale every 5 seconds because that's what we specified. And this is the Azure portal where I'm looking at this specific deployment of mine. And as you can see, it already started scaling here as well. We can see that here too. And what's interesting here is that we can actually see the node where this particular workload is running. Again, that's the combination between AKS and the virtual node. So although that I'm looking at the dashboard, etc. of my Kubernetes cluster, I can actually see that this isn't running on the Kubernetes cluster, but it's using the virtual node, the Azure container instances to do the actual work. The first pod actually started running, as we can see, which we can see here as well. There's 3 of them running, 4 of them running already. And it actually shouldn't take too long before this is going to scale back to 0, because there's only 100 items to process. Then KEDA will see that the queue is empty again, and it will scale it down. And there we go. It's been scaled down to 0 again. So that's how easy it is to get started with KEDA. Just to write an Azure function and get it deployed and get some work done based on events. So let's quickly move back to the slides to have a look at the second demo we're going to do. So in this second demo, we're gonna have a look at Prometheus and use the Prometheus scaler in KEDA to do scaling of an API that I've written in .NET Core. So Prometheus, to start with, is a time series database which you can use to store, for example, metrics. And it's an open source tool, and it's also been used by a lot of other open source tools as the storage of, for example, its metrics. So what Prometheus does is that it can scrape a metric source. So what I've done is that I've added a metrics endpoint to my .NET Core API, and Prometheus is able to read that metrics endpoint, fetch the metrics, and store that into its time series database. I then use KEDA to periodically pull the Prometheus database, perform a query on the database to get a metric out of it, and then do scaling based on that metric. So what you're going to see in this demo is that we're going to scale an API, a web API, based on a metric that that is in the Prometheus database. So let's go down to that example. So what we're seeing over here is my very simple .NET Core API. It doesn't do anything more than output a simple JSON value. So not too interesting there. What is interesting is the metrics endpoint I talked about. So this is the metrics data that I exposed, that my API exposes, and that is then also the data that Prometheus periodically queries and then stores in its database. This is the Prometheus tool. This is the dashboard, and besides querying the data here, you can also do some alerting and etc. The querying here in the dashboarding is pretty simple. So what you would mostly be doing is use this as a database and then use a tool like Grafana to query Prometheus and create dashboards and do some proper alerting, etc. So what we can do here is we can actually have a look in the database and create simple graphs out of the data. So that's exactly what I did here. I created a query on the Prometheus data to create the graph down here. And this is also the query we use from inside KEDA to get this metric and do the scaling based upon. So let's have a quick look at the API that I created. It's actually pretty easy to add Prometheus and the Prometheus endpoint to your API. It's this bit of code down here that you need to expose that particular endpoint. And then within your actual business code, we can do stuff like creating summaries or creating a counter. And then in functions, we can do things like increasing that counter or do an observe of a particular metric, etc. And that data will then be exposed in the endpoint I just showed you. And it will also by default expose things like the request duration and the number of requests, etc. And we're actually gonna do the scaling based on those metrics here today. So from a KEDA perspective, we need to again write ourselves a scaled object. It looks pretty similar to the one we saw before on the scaling on the queue, but this time, especially the trigger down here is different. It's now of type Prometheus, and it also requires a different set of parameters. So for example, it needs the address of your Prometheus server to send the query request. And it, for example, needs the query, it actually needs to run on the Prometheus database to get a value back to do the scaling based upon. So let's see how that actually works if we start running that. So what we see here again is the deployment on a Kubernetes cluster. This time it's a cluster running on my local machine. And we can actually see that. And what I did here is this actually is a full-blown cluster running on my local machine. And I've done that by using a combination between K3s and K3D. And K3s is a tool by Rancher, and it's a lightweight version of the full-blown Kubernetes. So what they've done is that they've replaced a few of the core components by simpler ones, and that makes it easier to run, makes it much smaller. So even quite simple hardware like a Raspberry Pi. Okay, thanks Siri. So even simple hardware like a Raspberry Pi is capable of running Kubernetes, a Kubernetes worker now. So that's pretty cool. And on top of K3S, I then use K3D, and K3D is a tool that allows you to manage your K3S Kubernetes clusters. So it's quite easy to then do a K3D command and say start up a particular cluster, for example. You can also run multiple, because as you can see here, I'm actually having multiple clusters available on my local machine, and I can just start and stop them on demand. So that's pretty powerful stuff to be running kind of full-blown clusters on your local machine. Because of the replacements they've done in K3S, it's a bit different from the full-blown stuff, but mostly it's enough to do your local development, etc., and do some more real testing than having just a single node cluster locally. So that's pretty cool. All right, so back to the demo. Let's have a look at the current deployment to see what's running. That's a typo. So as you can see, my application is running. That's the .NET Core Prom app deployment, and also Prometheus itself is running. And I have in another window already a command being ready, and I'm using the Hey tool. It's a simple tool written in Go that I can use to get some load on my server. So that's the address of the workload, and it's now going to query that workload. So if we then go back to Prometheus, then it takes some time for the data to get in Prometheus, because Prometheus is going to my API, my metrics API, each 20 seconds if I'm correct. So it takes a while before data comes in, but as you can see, data is actually coming in right now. So let's also make sure we can see the window over here, because it then shouldn't take too long, because before the threshold's being hit, and KEDA actually starts to scale out this particular workload, because the number of requests gets above 3, which was the threshold I specified in my scaled object. So as you can see, it's now starting to scale out, and at a certain point it will be done with scaling, because there's enough instances to handle the load. And then when my Hey tool is done with getting load on the cluster, which it is right now, it will also actually start scaling down back to 1 again, because we were scaling back to 0 in the previous example. But you can imagine that if you're running an API, you want it to be instantly and always available. So you want to at least run 1 instance of it, and in production probably even more. So that's always an option in KEDA, obviously. So again, we have this notion of the master and the workers. And especially when you're running your Kubernetes cluster in Azure, for example, AKS, then it's actually the cloud provider who will maintain your workers. It will do the patching, the operating system patching, etc. But what if you were running very long-running tasks on that worker, and then it's going to be shut down because your cloud environment thinks it needs to do operating system patching? So that's pretty annoying if you are running tasks on it that can take up to 10 hours, for example, of video encoding, and it's going to stop that in the middle. Then it's pretty hard to later on resume that work, so it's going to be lost. So there are a few things, a few ways in Kubernetes built in that you could use to stop your worker from being restarted or being updated, destroyed, etc. But that's far from ideal for these long-running tasks, because what happens is that your instance, your workload, actually gets a signal telling it that it's going to be shut down, and that gives your workload some time, by default 30 seconds, to wrap up its current work and close connections, etc. But that 30 seconds isn't enough for your long-running tasks. So there's ways to actually stop and hold the restart off for a bit. But there's problems with that. One of them is that, for example, somewhere halfway the getting killed, your pod, your workload, already loses its IP address. So that means there's no way anymore for you to connect to your workload or to monitor your workload while it actually still might be doing something. So that is far from ideal for long-running stuff. So luckily, there is something on Kubernetes which is called a job. And with jobs also comes a job controller. And it's the job controller's job to ensure that within a job at least one or more pods get executed and successfully terminated. And as long as that doesn't happen, the pods are not being cleaned up and jobs not being deleted, and therefore a machine cannot be restarted. So and the beauty here is that KEDA can actually also do scaling of jobs. So not only of the pods we saw earlier, the kind of default workload, but it can also do scaling of jobs. So let's have a look at an example on that. So what I did here is that I wrote a console application, a .NET Core console application, and that will be run as a job. So again, KEDA isn't just about Microsoft technology. KEDA isn't just about Azure Functions. You could kind of run whatever runs on a Kubernetes cluster can be scaled using KEDA. And if we're looking at jobs here, then we could even use something simple as a console application to do some work for us and then be scaled using KEDA. So, for example, what I'm doing here is that I'm reading a particular item from a queue again. This time I'm doing that myself because I'm not using an Azure function. So this would probably normally be a video encoding or some long-running thing. And then we also need to instruct KEDA again how to do the scaling of this particular job here. That looks a bit different from the scaled objects we saw earlier, because this time we're talking about a job and not so much about the normal one. So we also have a few different parameters to set. So for example, how many instances at the same time of a specific job you want to run, the number of completions, so there's a bit of reuse, etc. But again, then down here is again the image we want to run. So this will be then the actual job. In my case, it's the console application. And again, a bit of reference, etc. to my secret, so that it knows how to get to my storage account, and then do the extra scaling. So let's see how that works. Let's do a watch on the jobs. Currently there is one that's been completed already. And what we can do here is that we can add an item to my queue. Let's call it test, that sounds fine. And then it shouldn't take too long before we see that KEDA saw that message on the queue and it actually starts doing the scaling of that. And now it's actually done. So to see it actually working, we can have a look at the output of that thing. So let's have a look at it. So there's the output of the job, and it actually outputs the message that I have put onto the queue. So that's how easy it is to also be able to scale jobs with KEDA. So with that, that was the last demo I actually wanted to show you. So let's go back to the slides to wrap up here. So before I'm gonna thank you all, we should obviously first thank our sponsors for making this great event happen. It's almost the end of the day already. I hope you had a great day so far. So with that, thanks for joining my session. If you have any questions, you can place them in the chat and I'll answer them later on. But you can always reach out via Twitter, for example, or my email address. On my blog, there's the link. There's a post on how to do the first demo I showed you. So the blog post will lead you through how to set up the AKS cluster, the container instances, etc., and how to create your first Azure function and deploy it. So the whole first demo basically. And the last link is that of my GitHub account, and that's where I will upload the demo code, so you can also look that up. So thanks again and have a nice conference.